So there is a legitimately done and not cheated working. So I'm gonna miss the PSAT day Tuesday. Can I make it up on
Friday.
Friday?
Yeah. We have a lot of. I'm trying to think of what men did that was harmful for their bodies for thing, but it seems like all the things that for beauty is all done to women.
Not in Mesopotamia because they would put like sticks through their.
Oh, remember the? Do you know those people who put like the rings in their ears to make like the really big?
Yeah, men do that. Yeah.
Yeah, and then they have those open holes.
There's still some tribes in Africa that they think that having a long neck is sexy as well too. So they put these rings around their neck. Have you seen this?
Yeah, I have.
What it doesn't extend their neck. What it does is it pushes their shoulders down. So you get these people with these like giraffe necks.
Yeah, because they think giraffes.
And if they ever take the rings off, then their heads will collapse because they don't have the muscles because there's rings around their neck. Women in Western society used to wear things. They were called corsets, and so they would have these like shoulders, big hips, and their waist would be like literally this big. That's crazy. And they would like pull and tie these things and they used to be made out of whale bones too. I don't know what part of it, but they used to say whale bone corsets. That's kind of way off topic. How did we get on this?
I was talking about cosmetics in the Mayan.
Oh yeah, right. Okay. All right. I don't know if you watched the news, but something changed for the lower grades. They're going to do a different type of testing. We're still going to take that test on Tuesday, though. So you take your test on Tuesday. I will give you a packet that you can do on both Monday and on Wednesday. But you won't come to school, remember, on Monday or Wednesday. Yeah.
I heard a little birdie called Miss McCullough came and said that Thursday was also a day where he's.
I don't know. I'm still waiting for further clarification on that. So
if that does happen,
and then we'll just push this off.
That'd be a very interesting review because we lose 2 days and then we'll be done when we come back.
All right. Oh, I forgot to say you need calculators today.
Oh, dang it.
Really?
You want mine? You need it?
No, I got it. No, I'll bring this in case I get bored.
Wait, how do you do well? No, I didn't change the batteries.
All right, now you're gonna make me Google it.
Make me Google it.
Whale bone corset. I'm trying to imagine like which part of the whale was used.
I've
sir.
seen corsets because we had to use them for a musical we did.
Yeah.
For
Sir.
costumes,
What?
I forgot to change my batteries.
Here.
Oh no! We did this in 7th grade, right?
Probably. Oh, we don't need our book of truth today.
Oh yes, you do.
We do?
All right. Yeah, I won't be showing any pictures of that. Okay.
Oh, dang it.
I figured. Well, yeah, but I'm still curious. Just where was the whale bone part of that? But I will look it up on myself in my own free time.
people still wear.
They still wear corsets, but
They're not.
I don't think they're made of whale bones.
And they're not generally as tight as they used to be.
You guys probably don't know this, but it used to, like lighting used to come from whale oil.
Would you like
It was a very short period of time when, instead of using a candle, they would, I don't know which whales and where this oil comes from. I don't know if it's they reduce the blubber or something like that, but apparently you get some oil of some sort, natural oil, from whales. And for a period of time in the United States and around the world, that's how they used to light lights, is that it was called whale oil lights. I'm not sure why they burn brighter or something like that. Kind of crazy. And clearly that's why we don't do it anymore, because there's not enough whales to continue.
Well, maybe that's supposedly, but I could probably find more whales if I could swim the entire ocean.
Has anyone actually swam the ocean? I don't know.
I know someone swam the.
I think they've swum the Atlantic. I could be wrong on that.
I know that people have swum the.
All right, homework. This is a medium class. It's not super quick. It's not super long, but it's medium.
Wait, the English Channel to us, right?
English Channel is like 11 miles or something like that. I don't know.
Oh, okay.
It's pretty short. People, not only do they swim it like multiple times.
Do laps.
They do.
Wow. Well, let's see. We're doing
People swim from Cuba to the United States. That's a popular one to do too. That's 90 miles.
That's a lot.
Yeah, that's a lot.
I can do like 20 feet.
Before I'm
I'm not a
exhausted.
swimmer.
Probably the longest I've swum is like a couple miles, maybe 2 miles. I know I've done a 2 mile swim
I have
before.
a friend who goes to my church who's like a swimmer. She does like 5 miles a day.
Well, people run too, it's not unheard of.
Swimming takes a lot more energy than running.
I would disagree.
I don't know.
Well,
It depends on the stroke as well too. Like
Well,
if I do the breaststroke, I can do the breaststroke forever, like forever. I mean, it's
Yeah,
an
you
effortlessly thing. You know, if you do the, I don't know, the normal crawl stroke, that's definitely tiresome. But the breaststroke, it's like I feel like I could do that forever.
You should swim
Breaststroke is the one like this.
Hey, kids from more years ago. Yeah.
Kick your feet like frog. But the crawl thing is, like.
That takes energy.
And then the worst one is the butterfly. The butterfly.
Oh, butterflies.
I like
It's the one where you come out of the water.
I like the starfish one. You don't have to do
The starfish?
Yeah.
Oh, in the back. Yeah. I don't know. Yeah, that's relaxing too. That's why they teach you, and whenever you take a thing, they teach you drown proofing, and then you basically do dead man float, where you just basically put your head in the water and you float. And when you take some air, you put your head in the water. You do. You just float with your head down in the water. That's why it's called a dead man float. But I mean, that's like,
I thought you were talking about the one on the back.
you're not really swimming, you're just surviving. Okay, here we go. We haven't given circles any love for a while. Let's give some love today. All right, big picture, a circle. There's two formulas. You already know these formulas, by the way. There's the formula for and the formula for
C,
which is circumference. All right, so those are the two that we'll do today.
a lot of formulas. You can-
Technically, circumference is perimeter. Yeah, we're gonna get to the other couple ones tomorrow, right? Perimeter, except they don't call it perimeter. It's got a special name, circumference. This is also where the word pi comes from. I'll explain that here in a little bit. And then area. And so if you remember right, middle school teachers like to teach pi d, and it's because the area formula and circumference formula are so close together. They both have a 2, they both have a pi, they both have an r, that middle school students screw this up all the time. So a lot of middle school teachers, myself included, like to say circumference pi d. You won't see that in a book. They'll always say 2 pi r. Okay? And our book's going to use 2 pi r, but you can always use pi d.
Wow.
All right, it's geometry. I'm supposed to be able to prove everything. This is one of the ones I can't prove, right? At least not without calculus. So what I'm going to do is I'm going to show you a neat trick. Okay, it's not really a proof. It gives you an idea. All right. Recall that you can take a regular polygon and inscribe it in a circle, right? A regular polygon, put it inside a circle.
You can put any polygon inside a circle.
You can put some polygons
I mean, you
inside,
can't technically put any
not
inside
touching
circle.
all the vertices though.
Right.
Okay.
Can you put a
All
hand
right.
inside a circle?
Can you do
put a
what?
Circle?
You can put any triangle.
Oh,
Have you ever,
that.
you never seen the
Sir, can you put a circle in a circle?
Sure. Remember we did concentric circles
Yeah.
and we did tangents to circles, exterior, interior.
Can you put a circle that is inscribed with a circle?
Like, can you draw it?
But by its definition, I'm sure.
That's an infinite amount of circles.
I know.
In one circle.
I know.
All right.
We've already
Notice what happens as I make my polygon have more sides. Well, there's 4 sides. Does the area of the yellow equal the area of the circle?
No.
But as I increase the number of sides, what do you notice is happening?
It seems to get you getting closer. to
Getting
the area
closer
of
and
the
closer
circle.
and closer to the area of the circle. That's what we're about to do. The table that you see in front of you, we're going to try to get to the formula of the area of a circle and the circumference using this idea of, if you just put a regular circle inscribed inside of a regular polygon, inside of a circle, that eventually we should approach the value of the area of the circle. That's what we're about to do. Okay. So an infinite-sided regular polygon should be the circle. All right, so here we go. Let's start off as easy as we can with a square. Okay. We're going to calculate the perimeter of this square and its area.
Okay.
How many sides does the square have?
4.
Okay. I need to figure out the area of that yellow thing. Hey, how many numbers are up there? There's none. So we got to do something about that. So here's what we're going to do about it. We're going to calculate the area of this using the formula. Perimeter. We're going to calculate the perimeter. We would have to figure out the length of one side. Yes?
Yeah.
We do the same thing we did for area for the apophthegm. We're going to make a triangle.
Why do we have so much bit room? So
There's a lot of
Do
calculations.
we know what the radius is?
R.
Oh, okay. We can do
So
this.
we're going to make a triangle, right? Remember, this is a half of that full triangle. And since the square, there's 4 of the big triangles. There's an eighth of that one. Okay. All right. So I just drew it larger so we can do some ciphering
Could
here.
you
Oh,
say
this
that
is your
we're
R. If this is your R, then what's this?
That is R root 2.
We don't know that yet, and then we will eventually find something like that out. But
Well, no, it's
just in general, though, what would we call this?
it'd be R root 2 over 2.
Don't you're overthinking it.
A, yeah, but
A would be right here.
that is A because it's 45 degree, 45 degree.
This would be
A.
okay. I'm not going to argue that point, but this is in terms of the
Sure, B.
polygon. It's
Any number you want.
I'm going to go with what she said. Half of one side. What you said is right. It just doesn't apply to an octagon. Okay. All right. So that's a half a side, and we know that this side here is the apophysis. Don't need it for this one. So what I need to do to find the perimeter is I need to find out, well, not just this. I need to find out the whole darn thing.
You just need to find that.
So if I find that, well, I just basically solve for S, right?
You just multiply by 8.
Okay. We're going to use that same technique we used with the apophysis. We're going to do some trig. Okay. You remember for a square how far it was around the whole thing?
360.
So how do we find this in?
We just take it and divide it by 8.
Remember, it goes by 4 and then half of 4. And he said, let's do it easier. Let's just take 4 and double it, right? So what's 360 divided by 8?
150.
45 degrees. Okay. So that's this calculation right here. I'm going to use Ben's idea of.
The radius is bisecting it.
Okay. Say again?
But it's a 90 degree and the radius is bisecting it.
Agreed.
By common sense, you can figure out that that's a 45.
But what if
degree.
you're not common,
But
Jack?
watch this magic here, Jack. Okay. I'm going to use some trig. I'm going to choose. Remember, I'm trying to solve for S. I'm going to choose to use opposite. So that's either tangent or that's sine. I'm going to choose. You'll see why here in a little bit. I'm going to choose use sine. So the sine of 45, we figured that out. 4 sides. Divide by 4, then divide by another 2. That'd be divided by 8. Opposite would be 1/2 S. And the hypotenuse would be R. So here's your opposite over your hypotenuse.
Should be 2R sine 5 equals S.
So let's solve for S. So get rid of the R first by, and then how do we get rid of the half? Everything by 2. And here's the cool thing, which is why I didn't want to agree with him, which is I can get a number out of that. Right? His was true for this particular shape, but not true for all polygons. We can get a number out of that. So that's what one side is. Well, how many sides do I have?
4.
So therefore, instead of multiplying by 2, we can multiply by, and that will be the perimeter of that shape. So this is what you need to type in your calculator. Make sure you're in degrees. So it's 8 sine 45, which is about, let's round to 2 decimal places.
5.66.
A number.
So about 5.66.
Wait.
You'll see
You
why.
already have it multiplied by 2. Wouldn't you just figure out 2 sides of that?
No, because we wanted the perimeter of the yellow.
Right, but you're only figuring. Oh, never mind. Yeah.
All right, so boom, we found it out for 4 sides. 5.66 R. You might not know where we're going with this, but you will at the end. Cool. Is that square the circle?
No.
Well, how do we make this square look more like the circle?
Make it bigger.
Add more sides. So one more time. Let's do it for 6 sides. Hexagon. Hexagon isn't going to be the circle, but it's getting closer. Okay. Same process though. Do you remember the degrees for hexagon?
It's 30/60.
It's not.
For a hexagon.
It's a pentagon, Jack. Wait, yes,
Okay, yeah, make me look stupid then.
Well, what's the degrees?
30/60.
Is it 30/60?
It is. No.
So what are we dividing by? You told us to divide by.
Oh,
It was your answer. It was your answer. What did you say?
30.
No, what did you
by
say to
12
divide
get
by?
30.
Because I'm the one that said there's 6 triangles. Let's divide by 6. And
30,
then divide
12.
by 12. Thank you. What's
30.
360 divided by 12?
30.
So it is 30. He was right. 30 degrees. I don't want to go down the special right triangle. You're going to see why here in a little bit. Okay. Same process as we did before. Let's use a little bit of trig. Let's use sine again. So sine of 30 would be this over that. It's the same process. multiply by r, multiply by 2. How many sides this time?
6.
So 12. All right, type that into your calculator. 12 sine 30. Right at 6? Okay. What happened to our perimeter? Going up, going down, what?
Going up.
Going up. So as we get closer to the real thing, it looks like it's going up. Is it going to continue to go up?
Okay.
You want to cut to the chase?
Yes.
Now, I had this, multiple things. You can see how many columns here, but how do we make it more close to the circle? Okay, how many sides you want to add?
150.
All right, let's do 150. What will we have to
I'm adding
type in
100.
here?
I'm adding 150, so we're going to 156.
What we have to change this to do 156? Let's think about what we did. What's the pattern? Well, it was sine each time. What do we do with this number with that? What do we
So
do?
we just multiply by 2.
Double. So how many sides do we want to do?
156.
156.
So then we just do.
So it'd be what? 312 sine. Oh, now we got to get degrees. Well, how do we figure out that this was 30? What do we do?
Divide by double that.
Divide what?
300.
We divided 360 by double that, which was that number right there. Okay, that makes life a little bit easier. 312. And then was that it? Yeah, that was it. So what's that? 312 sine 360 over 12. And we have to type an R on it as well too.
6.3.
I want 2 decimal places.
It's 2.26.
No.
Okay, I was doing it in my head.
6.28.
6.28 and an R, right? So 6.28. Clearly we got bigger. Well, notice the pattern isn't that hard to do. We can make it ludicrous. Let's make it ludicrous.
6 billion.
6 billion?
Yes.
Let's do 6 billion.
Yes.
If it's 6 billion, what do I got to change that to though? 12 billion.
Okay.
So 12 billion, well, that's 12,000. That's 12 million. That's 12 billion. I hope your calculator can handle that. Sine
Let's do 12.
360 over 12 billion. 1, 2, 3, 1, 2, 3, 1, 2, 3. I don't know if you can put that in zeros. We're about to find out.
I have data.
Just do 1.2.
And I want it to 2 decimal places. 2
All right,
decimal
here we
places.
go.
All right, let's roll, people.
6.2.
We got 6.28 again.
That can't be right. 1, 2, 3. 1, 2, 3.
6.28. Wait a
6.28. So we're at 6 billion. I'm going to put billion. And we still got 6.28.
Do a smaller number. Do 300.
Oh, no. We want to do this because remember we said more sides, we're more approximating the circle.
We're just, yeah.
So somewhere between, I don't know, 100 or so, we get to this number 6.28 and it looks like it stays at 6.28. Like it doesn't change.
It doesn't change.
It actually does change, but guess what's
Just
changing?
By minimal.
What's changing is not the 28. What's changing are the decimal places to the right of that.
Right.
Those are changing, but the larger side, we can do it for, a trillion if we wanted to, you'd still get 6.28.
So why do we have so many boxes?
Sometimes it takes longer to convince students that this is actually true. So I had that many boxes just in case. So here's all the data, and I didn't do it for 6 billion. In fact, I stopped at 100, and at 100, we still get 6.28. So literally somewhere around 100, 30 was 6.27. We get to 6.28, and if we just keep it to 2 decimal places, stay 6.28 forever. Okay, so it looks like the perimeter is 6.28 R. Cool. Let's do area. What do we need to do to calculate area? Go back to the square. Usually kids are panicking in my lower class at this point because they don't know what we're doing.
Oh, you divide by 4. 5, 6, 6. And then,
Well, we're doing area. What was the formula for area?
oh, sorry. That's.
What was the formula for area from yesterday?
So you're doing.
1/2 PA, right? So it was 1/2 PA or AP, however you want to say it. Did you just break my calculator?
No, I realized I have a screwdriver.
You're a genius. I
All
got
right.
it. I cracked the code.
All right. Well, hold the punchline to let everybody else enjoy this. We know it has 4 sides. We already know the perimeter. We just calculated the perimeter for each one of these, right? We're going to start off with this line right here. We know the perimeter is 5.66 R. We need the apothem. So we're going to go back to our triangle. And this time, instead of solving for this side, I'm going to solve for the A. So what was this degree? It was 45. This time I want to solve for A. So this and that, I'm going to use what? Cosine. Let's use cosine. So cosine of 45 would be adjacent over hypotenuse. This one's easier because all I got to do is multiply by what? R. Okay. So A is equal to cosine 45R. That's what A is. Just plug it into the formula. So this would be 1/2 times A, which is cosine 45R, times the perimeter, which was 5.66R. All right. What's R times R?
R squared. R squared.
Now grab your calculators. 0.5 times cosine 45 times 5.66.
Times R squared.
Make sure you put a, we're going to leave R as R squared.
Don't we just divide to a half or?
You could. You can divide by 2 if you want to.
I
Just
know
make
we
sure
got
you
it.
close your parentheses right here before you multiply by 5.66.
Oh, okay, sorry, this
Okay, so we got 3. I'm sorry, 2.
Yeah. About
Why did I say
approximately
3? 2. So 2R squared. Okay, cool. All right, hexagon. What was the degree for hexagon? What was it? It was 30 degrees. Okay. Same thing. We're going to use cosine this again, a time again. So we got cosine of 30 equals A over R. Solve for R. I'm sorry, solve for A. My perimeter was 6R. So it's however you want to do it.
This
What do we get?
2.6 D.
Two decimal places.
2.60.
2.60.
Yeah, because it's 2.598, but the 8 rounds into the 9, meaning the 9 rounds into the 5.
So 2.60 R squared.
No.
Yes.
Oh, yeah. it is.
Okay. Same thing. You want to cut to the chase?
Yes,
Well, how many sides you want to do?
6 billion.
100.
When we saw that, as soon as we got to 100, we kind of got to a number that
Let's do 100 then.
Let's do 100.
But 6 billion is much bigger.
All right, we'll do 6 billion after this. Okay,
Oh, gosh.
but what was the
Let's do
pattern?
156.
The pattern was this thing right here. What was the pattern?
1/2 cosine.
With a cosine of the angle, you get the angle by 360 divided by double the number of sides. And then we got this from, well, this number right here, okay? And by the way, once it gets over 100, it stays 6.28. So we want to do it for 100. So it'd be 1/2 cosine of, yeah, but what was the math? 360 divided by 2, 100. Remember, double the number of sides, times, well, what we got right here. And there's another R, times an R, times 6.28 R.
can't
All right. Do the math.
It can't be.
Yeah, you figured it out.
Whoa.
Figured it out for you.
Well, yeah, because you did the math.
Yeah,
Well,
so
I
did
just
you.
did the math.
You could have done it earlier.
Can you guys stop arguing for
No.
1 second?
You'll get it in a second, Kelly.
Okay,
So basically,
What'd you get for an answer?
3.138455.
Rounded to 2 decimal places.
3.4? No, 2.
3 point.
3 points, it's 14.
so the
Oh,
area
it's
of
pi.
the circle.
You
is
got it now too.
You finally-
All right. So it
Well,
turns
actually, I
out,
figured it out from
and if
100.
you would want to do it with a billion, what the only thing that would change is it would still round to 3.14. The only thing is some of those decimals to the right would change.
Will be bigger. Yeah.
You know, so that's the big thing is the fact that as the polygon more approximates the circle, you kind of arrive at this number 3.14 R squared, and that's the formula for area of the circle, which is pi R squared.
Now,
What's this though?
Divided by 2.
So
3.141592654.
I like your 3.14. 2
R.
Pi.
2 pi r. Yeah.
by R. That's where that one is, right? 6.28 is just double 3.14. So there are your two formulas. This isn't really a proof. This is a, oh, look what I can do with a bunch of math in a table type thing.
Yeah, can we have the original proof?
I can, right?
Pretty-
Write this down and then I will show you the proof. All right, so yes, there's nothing new here today. Unlike, let's see, the rhombus, the half of the two diagonals multiplied together, and unlike a regular polygon, 1/2 PA, those are the only two new formulas we get in this chapter up until today. Tomorrow we do absolutely get new formulas that you've never seen before. But these we did in 6th grade, and 7th grade, and 8th grade. Well, you guys took algebra 1 in 8th grade, so we might have used this one time in algebra 1, pi r squared, but most of the time we don't use this in algebra 1.
But it's such a fun thing.
It is. I agree.
Also, there is an Avengers Endgame thing coming up. I don't know what else.
I don't like them actually.
There's the
Avengers Endgame.
there's a remake of the Justice League.
I have watched it. It is good.
I heard. It was on the radio this morning.
So wait a minute. If you have, so the more sides you get, the circle that you make gets closer and closer to just the radius.
So you got to say that again.
So if the triangle that you make from one radius and one apothem
Mhm.
gets closer and closer to just
The
being a
apothem
radius.
gets closer to the radius. Yes.
Yeah, so then
Yes.
eventually you just get a radius.
The apothem turns into a radius. Yes, true.
So really,
So really what you get from that triangle is
Really,
not
it's
a
just the
right
same
triangle,
thing.
it approximates a isosceles triangle.
so, well,
And this is actually a very large concept of calculus, which is you extend something a very large amount of time. So it's called a limit. And we'll talk about it 2 years from now in pre-calculus.
I wish I could just keep the pre-calculus.
I wish I could travel through the 10th dimension.
Okay,
That's not happening.
Trivia, this is the word in Greek, peripheria. We know that word as peripheria,
So,
periphery, right? That's the same word, right? This is where we get the symbol pi from. Do you see it?
Yep.
Because the Greek word peripheria starts with the letter,
B.
and there's your letter P in Greek.
Americans are like,
right?
ooh, pi.
And peripheria in Greek is what they say for the word circumference. So then that's why we use that symbol for pi. And remember, pi is circumference divided by diameter. All right, two things, and I know I taught you this in pre-algebra, pre-algebra, you may not remember this. You get to do two things with pi. One is, well, you round it to 3.14 and you do math with it. The second one is you do nothing with it. You just leave it as that symbol. That's called leaving your calculation in terms of pi. It's what you want to do. And when you get to algebra 2 pre-calc, you're really going to want to do it, because what it means is that you can cancel pi out with another pi. As soon as you make it into 3.14, you run into problems, because when you multiply, divide, or whatever, you're multiplying or dividing with a decimal number. If you leave it as the symbol pi, it's still 3.14, 15926, that sort. But you can do more cancellation and make a much prettier calculation. Tonight for homework, they're going to give you both. They're going to say, give me the estimate, and they're going to say, leave it in terms of pi.
I mean, it's not that hard. All I have to do is multiply it by 0.71428571143.
But just remember, you're rounding at some point. If you
Yeah.
leave it as the letter P, then it doesn't have to be rounded ever. And as you're going to see, yesterday we had the question, why do we have this thing called radians? It turns out that radians use the symbol pi. And it's very useful for canceling things in calculus and pre-calculus and higher level math in radians when you have the symbol pi and not 3.14. Okay, so in terms of pi, this is what an answer will look like. A circumference might be 2.4 times pi. Literally, all you do is you just don't multiply by 3.14.
okay.
A rounded answer, right? If you actually do that math, right, it's called an estimation or a rounded answer. Just be careful if it says leave in terms of pi, it just means that's it. You get to right here and you stop. You just leave pi as pi.
That means I can.
And it's simpler. All right, as easy as it gets. Area of a circle whose radius is 6. What's the answer? What?
Well, therefore the answer is 36 pi.
In terms of pi, but notice this one doesn't say that. Therefore, this is the ugly one that we actually have to do the math. Okay. But it's geometry. By the way, the PSAT test, the whole test is calculator. So just yank your calculator, you do the math. With a graphing calculator, it doesn't. I would probably always use the pi key for approximation. That way, you're much closer. It's actually fewer keystrokes to use the pi key than it is to type 3.14 too.
What's that carrot thing?
You see it?
Yeah.
Okay. Second answer. What's the second answer? Leave. This one says leave in terms of pi. Second one.
That's what Ben said before.
So what's the answer?
36 pi.
No.
36 times pi.
No.
Oh, it's circumference.
It's circumference.
McKinley did the same thing as before, so I was like, oh, it's 36 times pi.
I thought it was.
Allie's already said the answer. What did she say?
I heard her.
What'd she say?
She said the number.
Which was?
The answer.
Which was? For this one?
Oh, it's
This one is
30.
clear.
No, 12.
12 pi.
Wow, that guy's you took forever to get that.
6 times 2.
All right. Some calculations take longer than others.
Man, it was so hard.
All right.
You thought it was.
There's a typo on your page. I don't know where that word is. I put filed or something like. I have no idea what that word is there. But this is what it should say. It should say, you guys have seen these things ever on an airplane flying over the west, right? These are called. I think they're called point irrigation system or something like that, or point rotation. I don't know. Or pivot rotation, something like that. There's a big arm right here that's attached to this big long metal thing, and it's got wheels on it, and it goes around in a circle, right?
What mistake is there?
Filed.
On our sheet.
I have no idea why that word is there.
Oh.
I must have been copying from something, and I just didn't delete it or something.
I think it's just field. It's supposed to be field.
It could be. Yeah, that makes more sense. In this crop circle field, yeah, that makes more sense. All right. Okay, so what's the answer here? What are we gonna do?
Approximately how much of the field is irrigated? We're just gonna.
It's a pretty weak question because what does approximately mean?
We have to
Okay,
use
so we just have to.
4.
Yeah, but look at the picture.
We have to figure out what is irrigated.
So obviously it assumes that you know what it means to be irrigated.
Right. So the irrigated is the black part, right?
Some people might say, I don't know. I mean, so for someone from Colorado, we get this one. Brown means
Dead.
right. Someone from I don't know from Illinois might say, well, that's where the corn is getting ready to be harvested. I don't know. I'm making that part up. I'm saying this is a bad question that requires you to know a little bit about farming and understanding what brown and green means as well too. Agree. Like I said, this is from your book. That's why I don't like it. Oh, by the way, what are we doing here?
We're trying to find the circumference, aren't we? No.
Because it says circumference.
No, there's no circumference.
Doesn't say the word circumference or area. So which one is it?
It's
How much of its area?
Where are you getting that from?
It's the area of the green part. Because you don't
Kinley?
I feel like it.
That's what they're asking.
water the like the.
It says
very
approximately how much of the field is irrigated. If it's irrigated, it means it's got water. We assume that makes things green, right? So yeah. So what's the answer, by the way?
Right, who was right, Jack?
Well, no. I agree with him, right? What's the? How are we gonna get to the answer?
You just gotta figure out that angle. I don't know if I'm supposed to figure that out.
Oh, you do 430 divided by 2.
Because it's half the field that's irrigated, right?
Yeah.
No.
Yes, it's a pipe. No, no.
This is the key word.
All right, whatever. I'm just gonna do a quarter of it.
Yeah.
Yeah.
Does it kind of look like a quarter? I don't like this question. It's in your book. I mean, is that a quarter? To me, it looks like a little bit bigger than a quarter, but that's what they really want you to do. They just want you to figure out what's the area of the circle and take a quarter of it. Yeah.
What time do we get it on Friday?
This Friday?
Yes.
2.
2?
Okay,
Always.
thank you.
Why? Why would it be different?
I don't know. I forgot the time. I was like, just get out at 2:30.
Is this your first week, full week?
No, second.
Okay.
And my first.
So yeah, you're allowed to ask that question.
Okay, thank you.
You haven't been there. Do we have to use pi as well, I'm guessing?
It doesn't say so. So if you want to leave it in terms of pi, you could.
Yes. I don't like to do extra work.
So what's the answer in terms of pi?
46,225 pi squared. No, not pi squared, just pi. I know I wrote squared.
It would be meters squared because it's in meters.
Pi meters. Okay.
Where do you get 1,007? That's not.
If you don't leave it in terms of pi, that's what I got. Somebody better check my math because.
But that's just the area of the whole thing.
So we have to divide by 4. Yes or no? Or is that the final answer? You tell me.
You divide after you. That's after you divide it by 4.
Yeah, it's already defined.
That is divided by 4. I just didn't make it yellow. If you leave it in terms of pi, then it would be, I don't know, well, 4 squared is 16. So what'd you say, 160? But then divided by another 4 would be 40 again. So it's got a 4 in it if you're leaving it in terms of pi.
46,000.
Okay.
Yeah, that's what I got, but I don't understand where you got the 1060. Or not, where I got the 1060.
Did you use the pi key? Because I'm using 3.14.
Yeah.
Well,
I don't
that's
think
why.
that should change that much.
Yeah, especially for a large number, it's going to change it. It's not going to change the first 2 or 3 digits, but it will change the other digits. Because I stopped at 3.14. Yours is bigger than 3.14.
Yeah, that's good.
Good?
Yep.
All right, last one. Read it, McKinley.
All right, what is the circumference of a circle whose area is 25 pi? So we just put 25 pi.
Into what formula?
Oh, we just multiply it. No, we put it into the circumference.
Does it say that's the circumference?
No, that's the area. Sorry,
So we should probably put that in the,
area.
okay, so let's throw that into the area formula. Now what?
Then you just you cancel out the pi's.
Okay,
Then you just do 25. You square root 25,
okay.
and then you put r into the circumference formula.
R?
No, what a 5 into the circumference.
Okay, can you do that in your head? Because it says, it doesn't say leave in terms of pi. In terms of pi, the answer would be
10 squared, 10 pi.
10 pi. That was easy. By the way, you could do that in your head real quick.
1.4
I agree.
42.
I can
42.
3.1415.
Oh,
3.14159265.
Let's use the pi cube.
31.415265.
30.1.
And that's always in high school geometry. Boy, is the book really lazy about units. I mean, any middle school math teacher would hate this, but in high school, we're like, units, whatever. You get to science class, and they're going to be all over you if you leave off units. High school math teachers do a really poor job of enforcing the units to be used because you get really lazy in math.
You mean efficient?
No, I mean lazy because, like I said, until I started here, so I started teaching high school math, and I would hear it from the science teachers all the time. How come the kids forget to put units? I'm like, well, probably because I forget to tell them to put units, right? Because we're just happy that the math, we get to the answer. High school, scientists units are a very important part of what they do. Wait till you get to, what are you guys taking this year?
Biology.
It's biology. Wait till you get to physics. It's all about units and things canceling out and find out what it is. It's feet per second, or meters per second squared, that sort of thing. I do want your homework.
Hey, Jack, we have chemistry tomorrow.
Chemistry next year.
Chemistry next year.
Yes, but
And then
tomorrow.
physics junior year. Senior year is your option what you take.
AP bio.
AP bio,
AP physics. probably.
well, I don't know. We're certainly still going to have the other sciences that we're offering right now. So there'll be environmental science, astronomy, anatomy. There's a lot of kids that are signed up for anatomy.
Right.
A lot of kids are signed up for anatomy.
Yes.
If you take anatomy, I'm not saying don't take anatomy, but if you take anatomy as a sophomore,
So can you
then
show us
you
the
can't take it
real
as a senior. What?
So can you show us the real three?
Oh, yeah. Ready?
Yes. No.
There it is.
I can't see
You
it.
see how small the stuff is? And at the very bottom, what does it say? C equals pi d.
Oh, that can't be that hard to solve. I just need the right tools to do it.
You do. You need calculus.
Okay, can you give me a rundown of calculus real fast?
Calculus is two things. calculus is you draw a curve, a coordinate plane, right? You draw a curve. The first thing calculus says is anywhere along this curve, put a dot, and then make a tangent to that dot, literally, a geometry tangent. And calculus will tell you what is the slope of that tangent line. That's the first thing it will do. The second thing it'll do is from that dot, drop a line to the x-axis, and calculus will tell you how much is that area. That's all it does.
Doesn't it also?
And it takes a full year in high school and 3 semesters in college to teach you that in a book that's probably about 1,000 pages long. And the slope of the line is called a derivative, and the area is called an integral. And the symbol right here is a derivative.
It seems a little excessive, doesn't it?
And so the reason why that's important is how much water is in your
Probably
right here.
a cup.
So this is calculated using calculus because it's not a perfect cylinder, right? It's got corners and curves on it right here. If I start to pour this out,
So I'm taking.
calculus will also tell you the speed that the water will be poured out. Literally. Right? It's a really if there's a person that does math for a living, then most likely it's calculus
What?
because it's so useful.
Oh yeah, Hannah is taking German too. I told her that you were, and she was like, oh. She said it was-
Oh, that's sad.
Nobody's taking German too. I know, Joe.
Wait. So doesn't it also tell you the graph of the? Doesn't it also tell you the area of?
Tells you the area of the curve.
Of this. Can't you figure the area?
Well,
of
you have to-
This.
So when you do this area thing, so for instance, that one right there, what you do is you say, find me the area from X value here to X value here. So these are called setting your limits. So I want it, for instance, if this was literally the X value 1 and this was the X value 2. So you integrate this function from 2 to 1. And it will tell you how much area is right there.
So how does that help you get the area of a square or a circle?
Okay. Take this thing, rotate it along the x-axis. What shape did you get? Spin that shape right there, and you would get a base,
Yeah.
right? And you will do that in calculus as well too.
There. Wait, sir, just my calculator's dead.
No, you can't have mine.
Oh, are you sure? Can
Pretty
I
sure.
at least use it to?
You want that? Yeah. Just make sure I get it before the.
All right. I would totally not try to conveniently put it in my pocket and walk out the door without
Is that your?
All right, Madison's not online today. So Madison, if you have any questions, send me chat or email. That's it for today.